Okay, we have another linear equation, and they've given us a problem here. What we're going to do in this one is we're going to use elimination, and then we're going to check after to make sure we have the right answer. Okay, and it says here, a store sells CDs and DVDs. They sell CDs at $9 each and DVDs at $11 each. At the end of the day, the company has sold $204 worth of goods. They also know they've sold 20 items. How many CDs and DVDs were sold? So I've read through it once. Second time reading through it, I'm going to highlight what's important. I know that they sell CDs and DVDs. And I know they sell CDs at $9 each. And they sell DVDs at $11 each. Okay. At the end of the day, they've sold $204 worth of goods, and they sold 20 items to get that much money. What we're going to do is we're going to figure out how many CDs they've sold and how many DVDs they sold. Okay. So first thing we're going to do is we're going to set up a let statement. We're going to say let C equal CDs and let D equal DVDs. Those are going to be our two variables for this question. We have our DVDs, which is D, and we're going to have our CDs, which is C. We know that how many DVDs and CDs were sold altogether? 20, okay. So that we know the variable of C, so the number of CDs plus number of DVDs is going to equal 20. That's our very first equation. Okay. We also know the cost. So this is number of items. That's the first equation we made up, is number of items. The second equation is going to be cost or money worth. Okay. How much does a CD cost? Anyone remember? $9. There's $9 for a CD. And how much for a DVD? $11. Okay. So what this is setting up is that depending on the number of CDs times 9, that's how much money they would earn. And depending on the number of DVDs times 11, that's how much money they would earn from DVDs. How much money did they earn at the end of the day? $204. Okay. So we've set up our two equations. We have our number of items sold and the cost, or the amount of money they've made at the end of the day. We're going to solve this by elimination. So in order to do elimination, what do I need to make the same? Anyone know what that term is called? Number in front of the variable? What's that? Coefficient. Coefficient, that's it. Constant is a term with no variable. It's just a number, so these would be constants. The coefficient is the number in front of the variable, okay? So, looking at this, when I'm looking at both equations in a column here, well, my C's don't have the same coefficient, nor do my D's. So obviously I'm going to have to multiply one or both of these equations by a number. I'm going to try to get rid of CDs. Okay. So that means, because this is 1, I really only have to multiply the first equation. What do I need to multiply the first equation by so that C's coefficient is 9? 9. So I'm going to multiply every term in this equation by 9. Okay. So now we have two new equations. The new equation is 9C plus 9D equals 180. And we're still going to use the old equation. 9C plus 11D equals 204. Now notice I've numbered it still number 1, even though the coefficients are different. The reason I did this, if you guys remember back, we did equivalent linear equations. That's all we've done. It's the exact same equation, it just has different coefficients and constants in it. If we were to graph it, it'd be the exact same line. So it still represents the same equation. Now that we've done that, we can eliminate. Am I going to add or subtract to get rid of the C's? They're both positive. Okay, so we're going to need to subtract to get rid of them since they're both positive. So we're going to subtract these two equations. So we'll go column by column. 9C, subtract 9C, what's that going to give us? 0C. Okay? 9C, subtract 11. Oh, that shouldn't be a C. Sorry. Nobody picked that up. 9D. Subtract 11D. What's that going to give us? Negative 2D. And finally, 180 subtract 204. Okay. Negative 24. Good. All right. So now we can get rid of that 0C. We know that's going to just be the number 0. So we're left with the equation 2D is equal to negative 24. I need to get D by itself, so I need to divide both sides of the equation by negative 2. And it's going to turn out they are D, or DVDs. They've sold 12 of them at the end of the day. Okay? Now remember, I can substitute back in this D value into one of these equations, and quickly off the top of my head, if I sub 12 in for D, what's C going to be? 8, right? 12 plus 8 will give us 20. That's a really simple way to do it, and it's fine if you do it that way. But I just want to show you how we could use elimination to solve both. So I'm going to rewrite those equations. This time I'm going to multiply the first equation by 11. Okay, we'll do it in green. It's still equation 1, but it's going to say 11C plus 11D is equal to 220. Why did I multiply by 11? Anyone know?
Because D is 11.
D is 11. This time I'm trying to eliminate the D. So I need to make the coefficient 11 in this one. Okay? So we have 9C plus 11D equals 204. Again, because these are both positive, my 11Ds, I'm going to have to subtract in order to eliminate. So when I subtract, 11C minus 9C will give us 2C. 11D minus 11D will give us 0D. We bring down the equal sign. And 220 subtract 204 will give us 16. We're then left with 2C equals 16. We divide both sides by 2. C equals 8, which is exactly what we discovered before. Okay? Now in order to check, we have to use our method of substitution. So, we're going to jump down a little. We know the first equation was C plus D equals 20. Well, let's plug in 8 for C plus 12 for D equals 20. And is the left side equal to the right side? Yeah, we know that one's right. Number 2, the equation said 9C plus 11D equal 204. So again, we're going to replace C with the number 8. So 9 times 8 plus 11 times 12. And that should be 4 equals 204. So we're going to have to do this math. And okay, what's 9 times 8? Good. And what about 11 times 12? Not 136. 130. Good. 132 is equal to 204. Well, let's add them up together. 2 and 2 would be 4. 7 and 3 gives us a 10. Carry the 1. 204 equals 204. So it worked. We used substitution to check our elimination. So it's important that we still know how to substitute in order to solve. Okay? And we eliminated to solve both of them.